Hello, I welcome you all. The problem reads the conveyor belt is moving downwards at 4 meters per second. If the coefficient of static friction between the conveyor and the 15 kg package B is mu s equal to 0.8, determine the shortest time the belt can stop so that the package does not slide on the belt. Right, this problem is coming from the Engineering Mechanics and Dynamics, 14th edition by R.C. Hibbeler. So what do you think is happening right now? This package is moving together with a conveyor in this direction, and if this conveyor came to a stop, which direction do you think this particular package is going to slip? Of course, this direction, right? Inertia, all right, the tendency of a body to continue, okay, in the direction of motion, right? So it will tend to continue in this direction, but what will prevent this particular box to continue will be the friction between the box and the conveyor, right? So therefore our friction is supposed to be in which direction? This direction, right? This will be the direction of our friction force. Okay, is that fine? Great. So having established that, let me just isolate this part and draw it, okay, based on the explanation that I just gave. So I cut it out, and this is the box here. So what do we have here? We do have the friction. The friction will be in this direction, okay. The friction will be in this direction, and then I have the normal force in that direction, like so. And then let's say we have our what is that? Our weight, and then we have components. We have one component in this direction, one component in this direction, and then we have another component in this direction, okay. Right, then the angle, we have 30 degrees there. Let me just show what this angle is. So imagine if we have this horizontal line like this. This is 30, this is 60, and this is 30. Fine. Great, because this one here is 30, right? So this one becomes 30, right? 30, 60, 30. Is that okay? Okay, that is fine. So having established that, then we can write down our angle here, okay, which is 30 degrees. Right, so let's write down what we have. So this is our W, which is just equal to mg. This is our W, and this is equal to mg, and is equal to the weight of the package, 15 by 9.81, and this is just equal to 15 by 9.81. This one is 147.15. All right, and then we have this is W sine 30, and this is W cos 30, right? And then this is our Fs, which is just equal to mu s times n. Okay, move it a little bit backwards. See, this is Fs, which is just equal to mu s times n, and then this is our n, right? And this is moving at a velocity of 4 meters because it's moving together with this conveyor belt. So we are going to take draw our kinetic diagram in this direction, like so. We'll draw it in the same direction, like so. Okay, there we go. So this is our MA. Right, I think we've done everything that we need to do. So let's write down our equations of motion. Let's start with the y. Again, our coordinate, our reference coordinate is like so. Okay, this is our x and this is our y. It's positive values. So let's start with the y because we'll need our acceleration. So the summation of forces in the y equal to MAY, and we know that our AY is just equal to 0, and therefore we have our N minus W cos 30 equal to 0, and our N is just equal to W cos 30, which is equal to 147.15 cos 30. Okay, then our N, if we are to multiply that by cos 30, we just get 127.44 newtons. Okay, so we have our N. Let's sum up the forces. The equation of motion in the y. In the x, we have this, and we know our M is just equal to 15 kg. Then what do we have? We have W sine 13, that's our direction, which shows as our positive, minus Fs equal to Ma. Okay, and what do we have here? We have our W calculated is 147.15 sine 30 minus Fs is mu s, which is 0.8 times n, and our n is 127.44. Okay, 0.44. Alright, and this is just going to be equal to 15 A. So therefore our acceleration is just going to be equal to 147.15 sine 30 minus 0.8 times 127.44 divided by 15. So acceleration is just equal to minus 1.8918. Okay, or our acceleration is the other side, which is in this direction like this, and is equal to 1.8918 meters per second. So 147.15 sine 30 minus 0.8 by 127.44 divided by 15. Alright, so that is our acceleration. We've been told that this package is moving at 4 meters per second in this direction. Right. So, and we found our acceleration is going in the opposite direction. So we need to keep track of the signs based on everything that we are doing here. And this acceleration is constant. Okay, this is constant. It's just based on the weights. What else? Yes, just the weight itself is this is constant. So what we need to do now is compute this. Based on this constant acceleration, we need to calculate the time. So we can use this equation, v equal to v naught plus at, where our v naught is given here is traveling at 4 meters per second, and we are saying we find the shortest time that this conveyor can come to a stop. Okay, without letting this particular box to sleep. So we want the shortest time. Therefore, our V final, which is just our V, should be equal to 0 meters per second. We want it to go to 0. Okay, and we have our acceleration, which we calculated already, mind you, is minus, okay, 8919. Okay, because it's in the opposite direction, the acceleration. So we have 0 equal to 4 minus acceleration 1.8918 times t, and therefore our t is just going to be equal to, this is t minimum that we are calculating, this is equal to 4 divided by 1.8918. So this gives us a 2.11 seconds. Okay, so this is the minimum time. This is the minimum time. This acceleration, let me just show to say, is in this direction. Okay, it's in this direction, or it is positive. All right, so this is the minimum time that we need, or that the conveyor needs, okay, before it comes to a stop without this particular package slipping or sliding. So I hope this particular video was helpful, and if it was, give me a thumbs up, like my video, continue subscribing and liking my channel. Bye bye, and I'll see you in my next screencast.